The recent MV Hondius cruise ship outbreak has shown how quickly a little known rodent borne virus can move into the global headlines, triggering quarantine, repatriation of citizens, contact tracing, and public concerns in many quarters of the world. Hantavirus, like many other viruses, is serious, but it's also misunderstood. I'm Dominic Bowen, and I'm host of the International Risk Podcast. And today we're joined by Dr. Giulia Gallo. She's a postdoctoral scientist at the Viral Glycoproteins Group at the Pirbright Institute. Julia's work sits at that intersection of molecular virology, viral host interactions, and even the way that viruses enter cells, the way they evade immune responses, and sometimes even cross species barriers. Dr. Gallo is especially well placed to help us all understand what the hantavirus is, to understand virus transmission, zoonotic spillover, and how public health agencies can respond. And I think today's going to be a really insightful conversation. Dr. Giulia Gallo, welcome to the International Risk Podcast.
Thank you for having me. I'm looking forward to this conversation.
Yeah, I think it'll be a lot of fun. Now, whereabouts in the world are you today?
So today I'm at my workplace. So the Pirbright Institute is a little village in the county of Surrey in southwest England. So a bit 1 hour from London.
Very nice. I'm a big fan of Surrey. I've had some fantastic work experiences down there, and it's a beautiful part of the world.
Yeah, it is. It's very countryside. It's very friendly. It's very nice.
Wonderful. Well, Julia, if we look a little bit further afield, there was this Dutch flagged cruise ship which had passengers and crew from 23 different countries, including 9 European Union countries. And the virus has since been identified as the Andes hantavirus. And as of the 18th of May, there's been a total of 12 cases reported, I believe, including 9 confirmed, 2 probable, 1 inconclusive. And sadly, there's been 3 deaths. Now, this is a serious risk, but it's not a pandemic style threat yet. Now, for our listeners that have only just heard of the Hunter virus, what exactly is it? And perhaps more accurately, what do we need to know about this virus and this group of viruses?
So hantaviruses are not. I've been in interviews where, or I read comments where people were worried that hantaviruses are new viruses. And that's not the case. So hantaviruses have been discovered, first reported at least, we think during the Korean War. And the name Hantan actually comes from the river Hantan that you can find in Korea. So at some point, people, we think, report American soldier reported symptomatology that it's quite similar to what's reported for old world hantaviruses. And I can talk about the distinction between old world and new world hantaviruses later. But then the final proof came in the 70s, late 70s, when people isolated the virus Hantam from the first time. So it's been around for this, we are aware of it for like 50, 70 years. And when we talk about new world hantaviruses, and Andes is one of them, so it's all these viruses that are found in the Americas. The first cases of new world hantaviruses in people are being reported since the 90s. So there is nothing new about these viruses. What is new is that, as everyone knows, we are in a much more globalized, interconnected world than we were 30, 40 years ago. And so if now something happens, all of a sudden we are more involved, we are more affected by it. Beside that, hantaviruses are very, I would say, quite simple genome-wise. So they are quite a small genome, which is made of RNA, which is acid nucleic acid. And they are quite small, and they are quite simple. They encode for 4 proteins, which is not many proteins for a virus. And what we know is that they are hosted by rodents and different species of rodents. So as you might know, rodents is the biggest order in mammals and the most diverse. So it's not just house mouse or brown rat. It's a lot of different species that to us they all look the same, but to a mammologist, I'm sure they could tell the difference. And so different animals, different rodents can be infected by different type of hantaviruses, and occasionally this virus can be transmitted to human, and that's what we're seeing now.
And you talked about old world and new world viruses. That can sound quite interesting and certainly intriguing. Can you talk to us about the difference between old world and new world viruses?
Yeah, absolutely. So when we talk about new world hantaviruses or new world viruses, we refer to viruses that we found in the Americas, while old world we refer to viruses that we found in Europe, Asia, and Africa. And in the case of hantaviruses, it has been shown the new world hantaviruses cause something called hantavirus cardiopulmonary syndrome, which is what unfortunately the people on the cruise have been affected by. While in the old world, the hantaviruses cause something called hemorrhagic fever with renal syndrome. And that also shows us, just in the name, that these viruses, the disease they cause, affects different type of the human body. So in the new world, we will see a symptomatology that mainly affects the lungs and to lesser extent the heart, while in the old world, the main target of the infection we found is kidneys. So it's very the although the beginning, the onset of the disease is quite similar, so it's this prodromal syndrome, which is a febrile syndrome. So it's very specific flu-like. We refer sometimes of flu-like symptoms. After when the disease gets more severe, we can distinguish the two, along with, of course, tests that will confirm us if the person is infected by hantavirus and which species.
Okay, no, that's really interesting to understand. And we've also heard more specifically that this virus has been the Andes virus. So I'd love to hear from you about why this family within the Hunter virus is different from other Hunter viruses, and what actually means.
Yeah, so in hantaviruses, we found different species of viruses, and Handes is one of the species. And the reason why it's a bit different from the others is that for all the other viruses, as we know now, we have no cases of human to human transmission. So that means that if a person gets in contact with a rodent that is infected with the virus, it might get the virus, but then it will have a symptom. It might or might not have a symptomatology, and then the virus will kind of die in the person if the person survives. In the case of Andes, this is a bit different because being a human to human transmission, it means that if a person is sick and then gets into close contact with someone else, the second person can get infected by the virus. And that's why it's in a way much scarier than any other hantavirus because we need to be more careful about how we handle patient and how we put up a certain type of security measures to prevent the exposure of other people.
Yeah, and I think that's a really important point because we've heard public health officials right around the world, from the US Center for Disease Control to the World Health Organization, talk about limited human to human transition. And I think this is something that people need to understand because the implication is that transmission only occurs under specific conditions or in clusters, or that reproduction threshold is quite low. And I understand that can be because of the low viral shedding or the transmission period, or when people are most contagious. But can you help us understand with this virus, what are our public health experts actually saying when they say limited human to human transition?
The limitation we have at the moment with Andes is that we know it causes diseases and there are around 100 to 200 reported cases per year in South America. So in Argentina, Chile, Uruguay, mainly Argentina and Chile. But because potentially and I mean the cruise event seems to confirm it, it can be transmitted from human to human. Of course, it's much harder for us as scientists to study this virus because we don't want to expose researchers to the virus, so it has to be in high containment facilities, which are very, very expensive to run and very, very limited in number all over the world because of regulations. And so, unfortunately, when we say limited or close contact, it's because we ourselves are not sure we don't have data or enough data. We have circumstantial data from when we go back retrospectively and we study outbreak, as it has happened in Argentina in 2018-19. But we cannot. It's not very easy for scientists to go in the lab, grow the virus, and do all this kind of experiment that we can do with viruses that are less pathogenic in sense that the disease is not as severe as, for example, we can do with some type of flu, we can do with RSV, which of course they affect the human population, but not to the degree that we see hemorrhagic fever, which is something that of course really scares us, and we have really to be sure to protect the scientists involved. So unfortunately, it just means that we know what's happening, we have ideas and we have data, but we don't have enough data to be sure and conclusively say, we are sure this is happening. We understand exactly what's going on here. We are, as a scientist, we are also learning from what's happening on the cruise. And luckily we have, it's very clear based on other outbreak how we should treat the patients, so we know we have to give them support, respiratory support, exchange of oxygen. But unfortunately, above it, so like the molecular of the virus or the transmission of the virus, is very hard to study in the lab for us. So yeah, it's circumstantial evidence we have so far.
It's really interesting because I think the scientific certainty and certainty from a public health point of view is one thing, but also the public understanding of an outbreak is really important because I think that many people in the public and even journalists covering this story have perhaps confused points because whilst the hantavirus can be very severe at a personal level, it's got a low likelihood of spreading widely. So I wonder if you can talk us through that difference between individual severity and actual the wider population level risk.
Yeah, absolutely. So um, you have to imagine, this is a very oversimplistic way, but you have to imagine if you were a virus, so you infect someone, and the ultimate goal of the virus is to replicate as much as it can. And the perfect host, therefore, is not the host that dies. The perfect host is the host that is infected in a persistent way, so it can shed the virus over a long period of time. And that's what we see with rodents. So our rodents and hantavirus are hantavirus are well adapted to rodents. So we believe that once an animal is infected, the virus will persist throughout its lifetime, and there are conflicting reports, but we believe that the rodent will keep shedding the virus, and the virus will keep replicating without causing any disease in the animal. On the other hand, when a human gets into contact with a hantavirus, they are not very adapted to each other. And so what might happen is that there is a very, very severe response from the human body try to clear the infection, and that might cause, then we now believe that's might be the reason why we see hemorrhagic fever. It's just a overreaction in a way of the body to the infection. And so in a person that's infected, it's very, very severe. But on the other hand, because the person is very, very unwell, it's quite easy to isolate the person, control the person, and help the person survive. So it's a complicated question. That's how we think it works. That in a way, viruses, they are not so pathogenic to human. They can be to certain to what we call maybe the more sensible part of the population. So people that have a lower immune response, elderly people, of course, they're going to be affected. But unhealthy individual that's quite young as well might not be as affected, but still will propagate the virus. So that's why we consider hantavirus are very severe for the persons affected. But because it seems that the close contact is really required to be close to someone that's very, very sick, and the person cannot go around in the population, we consider that then the risk for the rest of the population is low.
Okay, that's really good to understand. And but Julia, your own research has looked at how the hantavirus proteins interact with humans. Can you talk to us about, what does the immune response and the human response tell us about why some hantaviruses can cause such severe disease in humans while remaining asymptomatic in other populations like rodents?
Well, we were very, very interested in this question, as you clearly mentioned, why these viruses cause such a disease in humans and not much in in rodents. And we found that depending on the virus and depending on the cell lines, so we have cells from human, we have cells for rodents, and when we infect them with other the antivirus that's specific to the rodent or to from or other antiviruses, we found the response was not the same. So in our heads, it seems that while in human cells, all these virus could cause with different protein a type of antiviral response. When we were looking in rodent cells, which of course is a model, it's an oversimplified model, but that's what we work with, we found that only the virus that's has evolved with the specific rodent could be productive. And when I say productive, I mean that the virus can enter and replicate, while all the other hantaviruses that never met this rodent, they didn't seem to succeed in producing new variant, no infectious variant. And so this was the main finding. And of course, there is still a lot to study. Just today, I was reading a paper from 2024 where people compare endothelial cells. And when I say endothelials, those are cells that are part of the vascular system that we have. And we can get cell line from human and from rodents. And we know the hantaviruses infect endothelial cells. And when we look at human endothelial cells, we find a strong immune response with hantaviruses. But when we take endothelial cells from rodents, in the specific case was a rat, and infected with a hantavirus, we don't see any immune response. So it seems to suggest this, that these viruses, where they are well adapted to the host kind of tolerates them, nothing major happens. But humans, there is a very strong uh, antiviral response that we think might be the cause of the disease we observe.
And I think, Julia, it's probably important. This is probably a good time in the episode to really dive into the really technical and dorky parts of science. But you work with viral glycoproteins and viral host interactions. So I think it would be good for us to understand, starting with, what are viral glycoproteins and why do they matter so much? What's the important thing that we need to understand about how viruses enter our cells, why they cause disease, and why they sometimes enable it to cross from rodents into humans.
Yeah. So when we talk about viral glycoproteins, those are the proteins. Glyco means they are glycosylated, so they are proteins which are made of amino acids, and glycosylation are sugars that are added that decorate our protein. And that's just the explanation of the name. And they basically are the exterior part of a viral particle. In the case of antiviruses, coronavirus, flu, RSV. And we are very interested in those because they are the first uh, part of, they play a key role in the first part of the viral cycle. So basically, they are responsible for interacting with the host cell and allow what we call viral entry, meaning that the virus can effectively infect a cell. And so that's why we are so interested in them, because we consider if this viral entry step cannot happen, basically we will not have an infection. And nowadays, a lot of therapeutics are now focused on this first part. So the vaccine for COVID, for example, it's based on stopping viral entry by forcing the human body to produce antibody against the viral glycoprotein of SARS-2. And we found a lot of therapeutics like antibody treatment, for example, in case of RSV, that's the same concept. We give to people mono antibodies targeting this specific aspect. That's why we are so interested in that, and we think it's important to understand what's going on.
Okay, thank you very much for explaining that. Julia, I wonder if you can talk us through what do we know about the cruise ship outbreak, especially the possible origin exposure on land, the evidence of onboard transmission, and even the role of the ship as a confined environment. I understand you've had some really interesting conversations with the World Health Organization and other experts on this topic. Can you talk to us about what we know and what we understand today?
Yeah, sure. So we just had a meeting on last Friday with WHO experts where basically I think one of the top priority was from the very beginning understand where people got the virus. Some people were obviously concerned that there might be rodents on the ship that were carrying the virus, and as I know, until now they couldn't find any rodents on the ship, which then kind of suggests that the leading theory it is at the moment that there was a couple, unfortunately, they both passed away, and they were doing some bird watching in Argentina and in some more secluded area, like rural areas. That's where, and we know, unfortunately, that's where the rodents that have this virus are from, and they might have contracted the virus there and then of course got back into the ship, and then eventually it seems that uh, you know how ships are, so we were comparing during this meeting how different the transmission might be outdoor. When you meet when you meet a rodent with a virus, usually it needs to be close contact, inhalation of viral particle, because maybe people are close to the excreta of viruses, but still we have UV from the sun, we have air, we have wind. While in a cruise ship, unfortunately, the space is quite secluded. So people are in close contact all the time. There is no UV. There is not as much change of air as we would of what we know outdoor. So we think that a cruise ship was a very peculiar situation where, because people are really in close contact, we don't have change of air, we don't have much UV, we don't in at the sea we might have a lot of humidity, especially from the part of the world. This all contributed to the cluster of outbreak that we saw.
Yeah, thanks very much for explaining that, Julia. I really appreciate it. And despite years of messaging during COVID, some people still think that hand washing is optional. They think that sneezing and coughing into their hands is fine. They think coming into the office and the workspace when visibly ill is a reasonable course of action. For ordinary people, what precautions actually matter, especially when it comes to travel and working in offices and I guess respect for society?
I think it's a really good rule that if you are feeling unwell, you should not go to work. Independently of all the virus, bacteria, infection, whatever is happening, you shouldn't. You do have to go to work and you feel a bit unwell to wear a mask. We still do that here. We still have a lot of alcoholic gel around the institute, and people. I think COVID was, of course it was awful, but for a lot of people was a good lesson, and I see a lot of people have kept their lesson in their mind. So I do see sometimes people going around with masks, washing their hands more than usual, and I'm not suggesting doing that for hantaviruses, of course, because the risk for the population is very low, but it's just a good practice for no matter which virus. We know these measures for any respiratory virus and for any virus or bacteria, just washing your hands or gel is a very, very good solution. So I think that independently of the antivirus outbreak, if you're feeling unwell, you still have to go out because it can happen. Yeah, just maybe you can, if you think it's respiratory, if your doctor says it's respiratory, just after consultation, do wear a mask, wash your hands more, try to avoid enclosed spaces, even if you have to miss, I don't know, a concert you were looking forward to. It's heartbreaking, but or the tube, I can think the tube it's awful for propagation of virus. So yeah, it's good measures that, in a world where sometimes it feels like we're some type of policy and government are becoming more narcissistic than ever and self-centered. It's quite good to remember. I think the big lesson we learned from the antivirus and the COVID was collaboration is more important than an international collaboration is what can save us, and readiness and be willing to share and be willing to get a bit less or on self-interest so the whole world can benefit.
Yeah, that's some great messages in there, Julia. Thank you very much for bringing those out. And I wonder, Julia, when guests come on the International Vest podcast, one question that we ask all guests is, when you look around the world, and I know you travel quite a bit, and you've got a fantastic international background yourself, what are the international risks that concern you the most?
I think nowadays what scares me the most, or I think it's a big risk, is what I see like geopolitical fragmentation, or the how much we rely is on interconnection. And I think the bigger risk is that if this interconnection come misses, and interconnection can be commerce, it can be internet. If I'm trying to think, if tomorrow internet is down for a week, I think it's going to be as bad as a lockdown, because a lot of people will not be able to work. And I think sometimes I have the feeling that everything it's a very it's an old machine, but it's not built to for unexpected. Anything that can be unexpected, we are not prepared for that. And I think that's the point, at least from our perspective as a scientist. I think we learned a lot from the pandemic, and I think the response we had for this hantavirus outbreak was, in my opinion, was more rapid. It was more engaging with the community. It was also in a way easier, because it was not something we did. As I said, we don't have asymptomatic people for now, but it was very good. It was, from my perspective, it was very good. A lot of people were involved. It was a very the communication was great, collaboration was great. Everyone had the chance to say what they thought.
Definitely, yeah. That's certainly a habit I have every night over dinner, to be grateful for a few things. You just have to be. It doesn't matter how grumpy I am when I sit down at the dinner table. Coming up with a few things to be grateful is a really good daily habit. But Julia, I really appreciate our conversation today, and really appreciate you coming on the International Risk Podcast. Thank you very much.
Thank you for having me.
Well, that was a really great conversation with Dr. Giulia Gallo, and I really appreciated hearing her thoughts on the hantavirus, on viral transmission, and how we should understand this rare but serious infectious disease without falling into either conspiracy, complacency, or panic. Today's episode was produced and coordinated by Edward Penrose. I'm Dominic Bowen, your host. Thanks very much for listening to the International Risk Podcast. We'll speak again in the next couple of days.